moment you may be thinking, wow, my head's spinning, what's all this about? Where did this come from? What is logic? It seems to have come out of the blue, but actually we're going to cover this quite a lot over the course. Nothing too in depth, nothing much more than you've already seen, so not a great deal to worry about. What I want you to do is watch this video to the end, because at the end I'm going to give you a sort of task to do in Python. Now, logic is all about computers. It's all a computer is, really. I know we've talked before about a computer just being made up of binary, ones and zeros, but actually inside that, or the use of that, is logic gates. And really there are only these three. So you only need to know how to draw these three logic gates. So the pictures that you see there are called logic gates: the and, the or, and the not. And we've got truth tables. You can see truth tables below. They look a little bit different to what we've already seen, particularly here where it says A and B. That's a bit of a strange symbol for and. This is A or B. That's a strange symbol for or. And this is not A with the line above the A. Yet another way of writing it down. There are 3 or 4 different ways of writing these expressions down, and you'll get used to them. You probably just stick with one, and we'll look at that when we do the exercise a little bit later in Python. But where do these come from? Why are these used, and why do you need to know them? Well, actually, if you are going to create printed circuits, let's go on to the next slide. If you're going to create printed circuits using silicon chips like this and a microprocessor, the CPU, the brains of the computer, is just billions of these things. And if I took the black plastic lid off the top of this, you would see what you've got below. And here, if the lid off this chip, and this chip is called 7404, so that would be the number of the chip. Inside there, we've got lots of NOT gates. In fact, we've got 6 of them. That's the chip. And if I took the lid off this 7408, inside there we've got 4 AND gates. And if I took the lid off this 7432, we've got lots of OR gates. And really that's all a computer is just made up of these chips. So that's why the logic is important. These diagrams are important if you were a designer of electric circuits and chips. They're not too important to us as programmers. However, the expressions that we saw, the A and B, are important to us, and we're going to look at that now. So if I go and take you back to maybe year 7, year 6, you played with Scratch, and I've got Scratch here, and you've got your typical little cat on the screen. Even Scratch has logic built in that you can write, and we have done it in programs, although you've probably not understood it at the time, and probably still don't understand it. But if I go to the operators, it's going to give me these green things where I can add 2 numbers together, I can take them away, I can multiply them, but I also get these down here, these logic symbols. I've got an AND, an OR, and a NOT. And you can see on the AND I've got 2 spaces to put variables, true and true, true and false, and so on. The same goes for the OR, but the NOT just has a single space for not A, not B. Later on in the course, I'm going to try to explain how to design programs in English using this terminology and or not. So what I'm trying to show you here is that the presentation showed you how we would do it if we were a circuit designer going into electronics, which you probably are not, and the programmer's version, which you definitely are and which you definitely will meet, which is why you definitely need to know these 3 gates. So I'm going to nip over now to Python and start you off, and I want you to complete by having a go yourself with the Python program. In fact, we're only going to do it in the shell. So let me see if I've got the Python shell on the screen. I don't seem to have it. Give me a second. And there we go, there's the Python shell. And I'm not writing a program, I'm just going to run this straight from the shell. I'm going to use the values true. I'm starting off with a capital T for true. If you write it lowercase, it won't work. Notice that when I type true with a capital T, it turns purple. But if I was to write that with a lowercase t, it stays black, saying it's not a keyword. So if I type true, and then use the logic statement and then write true, and press enter, it will tell me that the result is true. Let's see if I can go back to my presentation. So true and true would give true. And in the presentation on the first slide, we're looking at this A and B. So true and true is true. So A is true, B is true, the result is true. But notice that if I tried false for the first one, then wrote and true, I would end up with a 0, which is false. So let's whiz back to idle and show that working. If only I could. There we go. So what did I say? False. Oh, fleas. False and true evaluates to false. So that matches the truth table that we're doing here. So I've just done this one. False and true equals false. And we can do it for the other values as well. So this is my OR table, my OR truth table. Let's try this one. False or true. So I can type in false or true, and when I press enter, if you take a look, my value, my result should be true. And there we have it. So what I want you to do is investigate all of these. I want you to write all of these logic statements in the Python shell and convince yourself that you get the results that are in the truth table. You could also do it using ones and zeros, 1 for true and 0 for false. So let me show you how to do that. So I'm going to write exactly as I see in this truth table, a 0 and a 0, and I'm going to get a 0. So 0 and 0, press enter, and it gives me a 0. And to prove that's not a fluke, let's go down to this one. Let's do a 1 and a 1, and I should end up with a 1. 1 and 1, and I get a 1. So that's saying true, and true is true. And the same works for the OR. Let's try this one where A is 1, B is 0, and the result should be a 1. So let's do 1 or 0, and the result is a 1. So have a go. Try both the AND gate and the OR gate. Write these as true and false values, then write them as, or using 0 and 1, the binary values. And for a bit of fun, let's have a go at the NOT one. I'm going to start off showing you how to write it, but you can write the rest yourself. So I'm going to write NOT and then true. Well, if I'm not true, so this is true here. If I'm not true, my answer should be 0 or false. And there we go, we've got false. So up to you now, exercise, start up the shell, do those, all of those from the AND table, all of those from the OR table, all of those from the NOT table. Convince yourself that it works in a program or a language, sorry.